Welcome to Vision Plus and welcome back to this Senior for Mathematics. We are looking at equation of the tangent to a circle. Example 4. We are going to solve example 4 using two methods. The first method is what we call the method of the gradient function, where we simply need to find dy dx. Method 2 is the concept of perpendicular lines. So let me begin with method 1. And we are going to solve part A using method 1. Part A says that find the equation of the tangent to the circle x squared plus y squared plus 6y minus 1 equals to 0. And the point of tangency is given as ray -4. You must always keep in your mind that the point given here is what we are calling the point of tangency. The point of tangency is the point on the circumference of the circle where the tangent touches the circle. So when we are using the method of the gradient function, it is not necessary for us to sketch the circle. The main point is we must know that this is the point of tangency. So we are going to differentiate both sides of the equation of the circle with respect to x, which are treated as an implicit function. So dx of the function x squared plus y squared plus 6y minus 1, this is the left hand side, equals to, also differentiate the right hand side, that is dx of the left of the right hand side 0. This is the right hand side 0. So we're going to differentiate this with respect to x. If we differentiate x squared, we get to x. It is a function in x, so we say dx, but it was with respect to x, dx plus, if we differentiate y squared, what do we get? We get 2y. This is a function in y, so we say dy, but with respect to x, so we say dy dx. If we differentiate 6y, we get 6. It is a function in y, so we say dy, but with respect to x, so dy dx. If we differentiate a constant 0, if we differentiate a constant, it gives us 0, because any constant that we differentiate gives us 0. So if we differentiate 1, it gives us 0. So minus 0 equals to, if we differentiate also 0 on the right hand side of the equation, we also get 0. Now we need to find dy dx. So we need to simplify this expression. I'm saying this dy, so this dx are cancelling out. So here we shall have, therefore, we shall have 2x plus 2y dy dx plus 6 dy dx equals to 0. That is what we are saying. I've just only crossed out dx dx. So we need to make dy the subject. So what do we do? Let us have 2y dy dx plus 6 dy dx, this and this. Now I'm going to carry 2x to the other side of the equation to become negative 2x. Now let me factorize the left hand side so that I have 2y plus 6 dy dx equals to negative 2x. Now let me make dy dx the subject. Therefore, I'm making dy dx the subject. I will have negative 2x over, I'm going to divide both sides by 2y plus 6. So this is the gradient function of the circle that we are looking for. Gradient function of the circle. That is the gradient function of the circle. What is the gradient function of the circle? That is just a function that defines for us the gradient of the circle at any point on the circumference of that circle. But now we have a given point on the circumference of the circle. This is the point of tangency. So what will be the gradient of the circle at the point of tangency? So at the point of tangency, we are saying at 3 and negative 4, the gradient of the circle at point 3 and negative 4 becomes, okay, it becomes, we substitute for x and y. Where is x? Shall have been negative 2 into x. X is 3 over 2 times y, negative 4 plus 6. And then we find the gradient of the circle at that point of tangency. So if we have substituted well, negative 2, 3, yes. So negative 2 times 3, negative 6 over 2 times negative 4 plus 6, negative 2. This gives us here 3. Negative 6 divided by negative 2 is 3. So this is the gradient, okay, of the circle at the point of tangency. That is the gradient of the circle at the point of tangency. But what do we know? We know that at the point of tangency, the gradient of the circle is the same as the gradient of the tangent. Therefore, the gradient of the tangent is also 3. Is 3. Okay, now that we know the gradient of the tangent and one point on the tangent, we can find the equation of the tangent. So let me now say equation of the tangent. For the equation of the tangent, we have one point on the tangent, that is the point of tangent, that is 3 and negative 4. This point is on the circle and it is the same point where the tangent passes through. And now we also have the gradient m of the tangent as 3. So we can find the equation of the tangent from the equation of the line. The tangent is a line given by mx plus c. This is our x, this is our y momentarily. So we substitute for y, negative 4 equals to m. M is 3 times x, which is also 3, plus c. So that we find c, which c is the y-intercept. That is a point on the y-axis where the tangent meets that y-axis. So from here, I'm getting c as negative 13. C equals to negative 13. Because 3 times 3 is 9. We take it that side, it becomes negative. So that negative 4 minus 9 is negative 13. After getting c, then you come back. We only substitute for m and c in the equation of the circle. In the equation of the line is in the equation of the line. Therefore, y equals to m. M is 3. You then replace x. And then plus c. So we see is negative. So minus 13. So this is the equation of the tangent to this circle at the point of tangency 3 and negative 4 using method 1.